or afternoon or evening, and welcome back to another round of Algebra 2 Notes with Miss Faust. Today we're going to be talking about lesson 2.3.2. 2 is the unit we're on, 3 is the module, and 2 is the lesson in the book. So that's where those numbers come from. Our essential question today is, what is a complex number, and how can I add, subtract, and multiply complex numbers? Pardon the bell, but we're back now. I have tried to adjust some sound in the room, so hopefully the sound on this is a little better than it's been before. Please let me know. I'm always willing to work on that. So first thing we have to think about is, what is a complex number? So if you go back in your notes, you will see somewhere that you have written that I is equal to the square root of -1. Remember, that's the imaginary number. So anytime we have a number that has an I in it, then it is complex. So any number with an I is a complex number. So if you have a number with some imaginary part, that imaginary part automatically makes the number complex instead of being a real number. So imaginary numbers are complex parts. So any complex numbers always have a real part and an imaginary part. And we use a plus bi to represent complex numbers. And in that a plus bi, what we're going to look at is we're going to look at A. A is always the real part of a complex number. And then B is going to be the imaginary part of that complex number. So we have a real part and we have an imaginary part. And the idea behind complex numbers is that real parts can go with real parts and imaginary parts can go with imaginary parts, but real parts and imaginary parts can't go together. The good news is we have a way to make imaginary numbers real, and by the time we're done with that, you'll see that. So in order to look at a little bit of how we do operations with complex numbers, before we do that, let me just give you a couple examples. So if we had a number like -7 plus 3i, then the -7 would be the real part. And the imaginary part would be the 3. And when we're talking about the imaginary part, we don't say 3i. We know it's imaginary, so we know it has an I attached to it. If you had something like just -2i, well, in -2i, that's still a complex number, but it only has an imaginary part. It has no real part at all. So there's a hidden 0 there, just like when we're working with slopes and y-intercepts, and that would be the real part. So the real part is 0, and the imaginary part would be this -2. Okay, so numbers can have real parts and imaginary parts. Most of the numbers we work with are only real, but sometimes we have numbers that have both parts. So what that brings us to is how we can do some operations with imaginary numbers. The good news is that operations with imaginary numbers work a lot like operations with variables. So if you know how to add things with variables, you will also have a good idea of how to add things with real and imaginary parts. So let's do adding first. Adding complex numbers. So I'm going to do these side by side. I'm going to do something with variables over here. And then I'm going to do something with complex numbers over here so you can see how both of them work and how they compare. So a variable example would be if we had 3 plus 2x plus 8 minus 4x. And if you think back to working with variables, what we do then is we look for like terms. Like terms in this would be the 3 and the 8. And we add them, so 3 plus 8 is 11. And then the 2x and the 4x are like terms, so we do 2x plus negative 4x. 2 plus negative 4 is negative 2x. So our answer in this is 11 minus 2x. When we're working with complex numbers, we're going to have the same kind of thing happen. We have 3 plus 2i plus 8 minus 4i. So again, instead of looking for like terms now, we look for like parts. So we look for real parts, 3 and 8, which is still 11, and imaginary parts, 2i and negative 4i, and 2 plus negative 4i is just negative 2i. So notice the only real difference when we're adding is instead of having x's at the end, we have i's at the end. We still put the real parts and the imaginary parts together, or the like terms. I think of it like terms a lot. So moving on from addition, we can go straight into subtraction. The nice thing about subtraction is it's a lot like addition. So by seeing some subtraction examples, you will also see some more addition examples. So subtracting complex numbers. So if we have something like, again, I'll do a variable example and I'll do a complex number example. I think once you see one of those, then it's easy to transfer that into other problems. So our variable example, we might have something like 2 plus 5x minus 7 plus 4x. And depending on how you learned Algebra 1, you may or may not at some point have learned that when you subtract something in parentheses, you're really adding the opposite of what's in parentheses. So what we do is we change and switch signs. So really this being a subtraction means it's plus negative 7 and plus negative 4x. So I'm just going to rewrite the problem without the parentheses now because I don't need them anymore. 2 plus 5x plus negative 7 plus negative 4x. So then again we go through and we look for like terms. So we have a 2 and a negative 7. 2 and negative 7 together give us negative 5. And then our other like terms are the 5x and the negative 4x, and 5 minus 4 is 1x, or just x. So looking at how that works with complex numbers, we can use the same exact values. 2 plus 5i, so we have a complex number, minus 7 plus 4i. We're going to start the same way when we have complex numbers, so we change subtraction to addition and switch the signs of everything inside. So we get 2 plus 5i plus negative 7 plus negative 4i. And then we look for real parts and imaginary parts. Real, negative 5. Imaginary, 1i, or just I. So again, you can see our answers look really similar. This is 5 plus x. This is negative 5 plus I. Almost the same thing. We just are replacing our variables with those i's now, which represent complex numbers. Let me do one more example of subtraction just so you can see. So this would be example 1. This would be example 2. So another example of subtraction. Maybe I'll even do 2 more just because they're pretty... Well, actually, where most people make mistakes is when they're subtracting, believe it or not, because they forget to change this to addition and switch the signs after. So make this negative 3 plus 4i, change that subtraction into addition and switch the signs of everything inside, so the minus becomes a plus. So we get plus negative 8i and plus positive 2i. Find our real and imaginary parts. Oh, I made a mistake in that. This 8 never had an I in it. That's just an 8. There we go. Sorry about that. Negative 3 and negative 8 is negative 11. And 4i and 2i is 6i. So we get negative 11 plus 6i. And that's just going to take some practice remembering to do that, switching the signs. But, ooh, sorry. Ow, that was my knee. But I think once you guys get some practice in class, you'll get the hang of it. Having seen a couple examples will put you in good shape to be successful at this. So what we can get to next then, we've added, we've subtracted. Next, we're going to multiply. And when we multiply complex numbers, again, we're going to multiply complex numbers the same way we multiply things with variables. So thinking back, if you had something like 2x times x minus 4, in order to, so this is a variable example, sorry, variable, complex. And you don't always have to do both. Again, I'm just doing this to show you the process to try and connect it to something you already know. So 2x times x, and then 2x times negative 4. So when we do that, 2x times x gives us 2x squared. 2x times negative 4 gives us negative 8x. If it was a complex number, it might look like this. 2i times I minus 4. Again, we're going to start by distributing. So when we distribute, we get 2 times I minus 2 times 4, 8i. So we get 2i squared minus 8i. But this I squared, this is one of like the fundamental ideas about imaginary numbers. Remember, I is the square root of negative 1. Well, if you take I squared then, if you think about that, if you square both sides of this, when you square a square root, the square root goes away and you're just left with a number. So I squared is always equal to negative 1. So remember before when I said you can make imaginary numbers real, the way you do that is you multiply them together. So I times I, this I squared, we're going to replace with a negative 1. So we're going to make this 2 times negative 1 minus 8i. But 2 times negative 1 is just negative 2. So we end up with negative 2 minus 8i. So the big idea in complex numbers is anytime you get an I squared, not just an I, but an I squared, you replace it with a negative 1. Kind of hard to see on the lines of this. So I squareds always get replaced by negative 1, and then we finish simplifying. So that's what we're going to do over and over when we multiply complex numbers, and I'm going to show you a couple more examples now. So this, again, think back to Algebra 1 when we multiplied binomials. So multiplying continued. I know many of you don't use nearly as many pages as I do for my notes, but I like to keep it so that you can see it and understand it. So if we have 1 plus 3i times 4 minus 2i, it's two ways that we've done this in algebra. Some of you learned a box method and some of you learned FOIL. For this problem, I'll show you both ways, and then after that, I'll let you start to pick which way you want to do it. So if you use FOIL, and if you've heard of FOIL before, great, use it. If not, watch, see if it's something that makes sense to you. If it's something that makes sense, it might be something you want to start using when you're multiplying binomials. So the idea behind FOIL is that you multiply the first two terms. So the first two terms you get 1 times 4. Then you multiply the outside two terms, hence the O. So 1 times negative 2i is negative 2i. Next we have an I in FOIL, so we multiply the inside terms. 3i times 4. 3i times 4 is 12i. And finally, we need to multiply the last two terms, L for last. So that's the 3i and the negative 2i. 3 times negative 2 is negative 6, and I times I is I squared. Now we have to do a little combining of like terms and simplifying. These both have i's in them. So 1 times 4, I don't know why I didn't just write 4, but whatever. Negative 2 plus 12i would be positive 10i. And then we get this negative 6i squared at the end. So remember, that's a negative 6, and the I squared is going to get replaced with a negative 1. So what that really becomes is 4 plus 10i. Negative and negative make that a positive 6. Now we simplify that even further because we suddenly have another real part. Imaginary number squared, turn real. 4 plus 6 is 10. So our answer is 10 plus 10i. So that's one way to do this. The other way, and if you always use FOIL, watch the box method once, see if you like it. You can pick which one you want to use after this. I just like to give you all the options. So we have 2 terms here and 2 terms here. So we're going to make a box, hence the name box method. Make sure my box is big enough. I didn't count, so it's probably off a little, but you'll forgive me, or you won't, and that's okay too. 1, 2, 3, there we go. Okay, so I take my 2 terms from this and I put them across one side. So 1 and 3i. I take these 2 terms and I put them down the other side. 4 and minus 2i. And I just want to remind myself that I'm multiplying these. So I fill it in like a multiplication table. 1 times 4 is 4. 3 times 4 is 12i, because I have the I there. 1 times negative 2i is negative 2i. 3i times negative 2 is going to go here, so 3 times negative 2 is negative 6, and then I and I is I squared. So you can see we get the same pieces here that we had over here when we did FOIL. We just get them in a slightly different order. Doesn't really matter because we have to put them all together at the end anyway. So I just wrote them out in order. 4 plus 12i minus 2i minus 6i. Put the i's together. 10i. I squared is negative 1. So minus 6 times negative 1, but that just becomes plus 6. And I get 10 plus 10i. Same exact thing, just a different way of getting there. So either way is totally fine. And sometimes you'll end up with imaginary parts, sometimes you'll end up with real parts, sometimes you end up with both. We'll continue to look at this and do more examples in class next time, but hopefully this has been a good introduction to complex numbers and how to add, subtract, and multiply them. Thank you very much and have a wonderful day, Mustangs. Woo!